Hello friends, welcome to Mechanical Engineering online classes. Today's lecture will be delivered by Miss Shravani Sriramoju.
In our previous videos, we have learned flow shop scheduling, where we have learned the sequencing of n jobs through 2 machines and n jobs through 3 machines, wherein all the jobs have same processing order. This is applicable for a product layout. Today, we shall learn to find a sequence for a job shop with 2 jobs going through M machines, where each job will have a different processing order, and this will be applicable for a process layout. Let us try and understand this job shop scheduling with the help of an example. Processing 2 jobs through M machines. Before going ahead to solve the problem, let us see the assumptions. The first assumption is that the technological order of these machines to execute each job is known, including the processing times. And the objective is to minimize the total processing time T and the idle times of machines and jobs. In order to solve these kind of problems of processing 2 jobs through M machines, we use graphical method. Let us now solve a problem. The question goes like this. We have to find the optimal sequence to process job 1 and job 2 on 5 machines A, B, C, D and E. The processing order given for job 1 is A, B, C, D, E, and the processing times are also given. So job 1 needs first machine A for 1 hour, then it needs machine B for 2 hours, then it will go to machine C and it will be processed there for 3 hours, then D 5 hours, on E it is finally 2 hours. So this is the processing order and the time for job 1. Similarly, job 2 processing order and time is also given. So the processing order of job 2 is, it will first go to C, machine C, and there it takes 3 hours. Then it will go to machine A, there it takes 4 hours. Then this job 2 is going to D machine for 2 hours. Then it goes to E machine and it will be processed there for 1 hour. And finally it will go to machine B and there it will be taking a processing time of 5 hours. So that now we have only machine A, which is only one of its kind. Machine B also we have single machine B, only one machine of C kind, on one machine of D type and only one machine of E type. So with these 5 machines, the 2 jobs must be processed, and we have to find the total time that is needed to complete both the jobs. And we should also find which job is going first to a particular machine. To solve this problem, let us take a graph sheet and we shall plot job 1 on x-axis and job 2 on y-axis. Now let us mark the machine sequences on the axis with the time scale. After 1 hour, it will stay with machine B for the next 2 hours. So the next 2 hours is this. It will be with machine B. Then for the next 3 hours, it will be with machine C. Then for the next 5 hours, it will be with machine D. So 5 hours from the 6 is 11. So all these 5 hours, job 1 will be with machine D. And the last 2 hours, it will be with machine E. So job 1 will require a total of 13 hours. It is 1 plus 2 plus 3 plus 5 plus 2, which is this 13. In a similar fashion, let us mark all the machines with their time scale on y-axis along the job 2 axis. Job 2 will first go to machine C for the first 3 hours. Then after this 3 hours is elapsed, it will be with machine A for the next 4 hours. So 4 hours from this particular point is 3 plus 4 is 7. So by the end of 7 hours, it will be done with machine C and machine A. Then for next 2 hours, it will be with machine D. For the next 1 hour, it will be with machine E. And 5 hours, it will be with machine B. The total processing time that job 2 requires for all the process to be completed is 3 plus 4 plus 2 plus 1 plus 5, which is 15 on a cumulative basis. Now let us draw the regions on the graph where a machine is on duty. For example, let us see which area A is blocked with. We are extending this A here, and from here also we are extending A. So this is the area where machine A is fully occupied. So we are projecting the A time from x-axis and also from y-axis, from job 1 and job 2 axis, and we are drawing the rectangle. So this rectangle shows that the region shows that A is occupied during those times. Just like that, we have to show where every machine is busy. So next, let us try to identify the block B. For machine B, you just extend these and they should intersect with the B that is there on x-axis. So this area, this rectangle shows that B is busy. So this area is covered by machine B. Similarly, let us see where C comes. So C is somewhere here on job 1 axis. So let us project it upward. Where it is intersecting with the job 2 axis? This region. That is this. So this closed rectangle is the area blocked by C. In the same fashion, we have to locate the intersection of D for both job 1 and job 2, which will be this, and for E it will be this. Now our graph sheet is ready, and from this we can find an optimum path. As we have already discussed, job 1 requires a total of 13 hours and job 2 requires a total of 15 hours for all the processing to be completed. So if this is the starting point, then this will be the finish point where 13, 15, by this point our job 1 and job 2 processing will be completed. So let the start point be origin O and the last point, finish point, be point Z. Now when we are at origin O, we have to reach to this point Z. So within the graph you can move in any path, any way to reach Z, such that both the jobs are completing its processing. But one must not forget that the blocks A, B, C, D, E are the places where these machines are busy and we cannot travel through that. So we have to choose a path which is not intersecting with these pink color blocks. In order to find the shortest path, if you see, this is our job 1 axis or the x-axis, this is job 2 axis, this is y-axis. I want to reach this point Z from point O. Because the scale is of a time scale, in order to reach the shortest time to Z, it should be the shortest distance on the graph. So the shortest distance will be a straight line from O to Z, which is 45 degrees from either of the axes. So as we are traveling from O to Z along this 45-degree line, job 1 and job 2 are simultaneously happening. So this 45-degree line is the optimal line. But since that we cannot draw a line or you cannot choose a path which is intersecting with the pink blocks, we have to see that whenever there is a intersection or otherwise where there is a obstruction, we have to go along the rectangular block. For example, here in this problem. So let us try to see if this particular problem has an optimal solution where the path is exactly this 45-degree line. So let us try and draw 45-degree line from O to Z. Now we can see that there is an obstruction or interference with the machine D. Machine D is busy there. So we are not supposed to take this path. We can take this path only up to a certain limit. That means only till here. So let us see from where up to where we can draw this 45-degree line. So from origin to 3 by 3, it is the vertex of the C block. Then this is 6 by 6, 6 comma 6. We can go till here 7 comma 7. So this is one path. So till here we can pass, we can go on this 45-degree line, and then we can go ahead like this along this edge, and then again take a 45-degree line here, and then again move vertically upward to reach point Z. What a horizontal line or a vertical line means is that here in this particular zone we are moving horizontally rightward, means the time zone on for job 1 is happening, but along job 2 it is idle. Job 2 is idle there. So when we are going in a 45-degree line, both the works for job 1 and 2 are simultaneously happening. Now once we reach at this point, now we are moving vertically upward. So the job 2 scale is running, means from E to B. This is happening, this work is happening where our job 1 is idle. So we have to see that the number of horizontal lines or vertical lines must be less in our path. Also that even if the horizontal and vertical lines is inevitable, like here we have obtained an obstruction here, so we'll have to move horizontally, but we can see that the length of the horizontal or vertical line is also less. So length of a horizontal line is less means the idle time of job 2 will come down. Length of vertical line being less means the idle time for job 1 will come down, like that. So what we are seeing here is the black line is one path, and as I just told, we can reduce the lengths of the horizontal or vertical lines. So for that, if we shouldn't go on a 45-degree line till this point, we can stop here and then go up straight over here. So once we go up straight here, from this point we can again take a 45-degree line. So we can go like this also. So we can go like this, rather hitting D. If we just move vertically up here itself, then the number of horizontal and vertical lines is also coming down, and even if not that, the lengths of these vertical and horizontal lines is coming down. So the waiting times or idle times are coming down. So this red one is another path. In the same fashion we can find another path. Say for example we are traveling here, then let's go along the D border. In the black path we have taken again 45-degree line, otherwise we can go like this also. So vertically along D border, then horizontally along E border, and then from there we can go vertically to point Z. So this is another path, and just by visual inspection we can say that this is a very long path, because we are almost walking through the borders of two borders of D and two borders of E. but this is another path. Of all such paths, we have to find the path with minimum processing time and minimum idle times. So if we are choosing the red path, let us see what is the total time. So from here, from 00 to this particular point, it is 6 hours. So within 6 hours, job 1 has completed going to machine A, B and C. Job 2 also completed C, A. So till this point it is 6 hours, plus from this point to this point, this length of the line is again 3 hours, from 6 to 9. So that is plus 3 hours, plus again this is 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. 6 hours plus this 1 hour. Total processing time for both the jobs to be completed is 16 hours. So if we choose the black path, from origin to this point it is 7 hours, plus we are walking horizontally from here to here, from till here it is 7 hours. 7 hours plus 1 2 3 4 hours, plus these 2 hours, plus from this point to here it is 1 2 3 4 5 6 hours. The total will be 19 hours. In case we choose the yellow path, it is from here to here it is 7 hours, plus this is 4 hours, plus this 2 hours, plus this 2 hours, so 2 plus 2, plus this 1 2 3 4 5 6 hours. The total is 21 hours. So of all the paths that are considered, the red one is giving us the least total processing time. So red path is our optimal path, this one. Now let us find the idle times for job 1 and 2 for the red path. For any path we can find, but because red is the optimum path, we will find idle times for that only. So as I told you, the vertical line means that job 1 is idle because the time is not moving on job 1 axis. A horizontal line means that job 2 is idle. So here there is one vertical line between this and this point. So the length of this is 3 hours. So 3 hours job 1 is idle, and again simultaneously the processing happened in this zone and in this zone. Here job 1 is idle for 3 hours. Here job 2 is idle for 1 hour. If you drop down and see this length, it is 12 to 13, which is 1 hour. And the minimum total processing time is this 16 hours. So this is how we will solve a problem for 2 jobs going through M machines using graphical method. Most importantly, what one should remember is that drawing lines into the blocked areas is restricted, and draw as far as possible the 45-degree line, because that will give us the shortest distance and hence the shortest time. So the minimum processing time, the total minimum processing time is found. And there's another question in this: determine the job that should be done first. So what is completed first? So by this time, by this point in the path, our job 2 is completed. So the last 1 hour only job 1 is happening. So job 2 is completed first. And it is because of this reason that job 1 is happening for the next 1 hour also. Job 2 is idle for that 1 hour. Try to solve the following problem. Comment your answers below.
Thanks for watching. If this video was of help to you, please like it and share it with your friends. And don't forget to subscribe to our channel.